All right, let's go over the answer. So if you are doing the structure and bonding, can you take your headphones out, pay attention, because I'm giving you the answer for this and walking you through some of the common areas of mistakes. Cool, and let me just help you process this. So what I'm going to do is just kind of show you guys some key things, and then what I'll also do is show you the marking schedule as well. Question number 2 is your types of substances question. This was the material that we learned at the very beginning of the year, so it's probably rusty. The other thing that's kind of challenging about this question is that there's lots of writing. There's lots of layers you need to have into your answers. And it's very easy to kind of make a mistake on this. And the errors, unfortunately, really kind of carry through if you're not careful. So the first thing you often see with these types of solids question is your little table. So they've given you some information to help kind of give you background. So they say copper is a metal used in integrated circuits. This is so ridiculous. They told you copper is a metal and you are trying to classify types of solids. So what type of solid would that be? Solid. Definitely a metal. Yeah? Isn't that ridiculous? They've given you the answers in that one. All right. It's used in circuits. The circuit thing is helpful to kind of remind me, and I can use that as another hint. When I think about circuits, they're obviously electrical conductors, so that's something else I could note. So that paragraph there was actually really helpful. It's giving you 2 things that you can use later. Unfortunately, copper corrodes to form copper oxide. Complete the table below by stating the type of substance, types of particles, name bonds between the particles for each type of solid substance. This classification of your type of solid is really, really important. This often will carry down into later sections of the question. So if you misclassify it, that error is going to carry through and it's going to really hurt your grade. So make sure to take your time and kind of think about it before you start just putting things down and answering the question. So that's kind of my first thing to kind of recommend with this one. The other thing to keep in mind is that the types of particles and the bonds between those particles is also important to get right because you're going to be using that later in your answer as your justification. So it's best not to rush it. Some things to remember when we're thinking about categories is the types of particles that are available for you to have as choices. I see a lot of people making mistakes in this section. So be mindful you have 3 choices. It's atoms, it's molecules, and then your last choice is ions. Those are the only 3 things you should be writing down the types of particles. Those are your 3 choices. So be really kind of mindful about which one you are using. I do have a summary table of this somewhere on the Google site, just kind of giving you the generic metals. You'd have atoms, this, you'd have that, etc., etc. In most cases, it's relatively obvious. So hopefully you guys can get it. All right, so copper, we've been told it's a metal, luckily, already. The particle is going to be atoms. And then the bonds between them is just metallic bonds. So this stuff should be really kind of hopefully easy to fill in. The other thing to keep in mind when you're looking at your types of substances is to use the periodic table because that's going to help you classify it. You don't want to make a silly mistake. So when I'm looking at it, I know copper is a metal, and my oxide, the oxygen, is going to be a nonmetal. So since I see that combination of metal and nonmetal, I automatically know that it can only be the ionic solid. And with the ionic solid, then the particles have to be ions, and then it's just an ionic bond. So a lot of it's pretty logical. We good so far? All right. Silica, which we see is silicon and the oxygen. If I look at that, both of those are nonmetals. So from initially, I can already tell that this is going to be covalent in some way. Now, I may not know at this point, if you don't remember, that it's covalent molecular or covalent network. So we're just going to write covalent for now. I'm going to leave everything else blank. Because let's say you can't recall from your memory if silica or silicon dioxide is a covalent network or covalent molecular. Read the rest of the question to see if there's any sort of hints that you can help. So let's see what else it says. It says, during the process of making copper suitable for integrated circuits, the copper is briefly heated to 500 degrees Celsius. This is about half of the copper's melting point. Explain why melting point of copper is so high. So that doesn't give me any hints about the silicon dioxide, so I'm going to keep reading. Don't feel like you need to answer this in order. You can, and I highly suggest that you read it before you start answering the question, because there's usually lots of hints, especially in the types of solid question. So next thing here is it is important that silica is integrated in circuits is hard. Explain why silica is hard. So that is a physical property of it. And already from there, I could start connecting my dots and think about it. If it's hard and it's being used in circuits, it must be a solid at room temperature, right? So from that hint there, that can then help me figure out if it's covalent molecular or covalent network. Because we know if covalent molecular, I'd expect it to be a liquid or a gas at room temperature. So that tells me that this must be covalent network. Do you see how I got that? And we don't, like I said, if you fill out this table incorrectly, that error will carry through. So if you misclassified the silicon dioxide, it's going to affect this section here. So covalent networks is atoms. So the only one that uses the molecules is the covalent molecular, obviously in its name. The only one that uses ions is ionic solids. Again, it's in its name. So it should be really, really obvious. In the covalent networks, this one has your covalent bonds. Be mindful in covalent molecular, you'll be writing down intermolecular bonds because of those weak forces. So just kind of keep that in mind. Remember, we're asking what is the bond that's holding the solid substance. So even though there are covalent bonds in the covalent molecular, that's between the atoms. And what makes up the solid in the covalent molecular is the fact that the molecules are attracted to each other. Yeah? So just be careful of those sort of things. All right, I think this stuff is pretty kind of straightforward. I'll show you the marking schedule for that. I'm just kind of helping you process when I'm showing you this stuff. This one has compare and contrast the electrical conductivity and ductility of copper versus copper oxide. Whenever you see that compare and contrast, I really want you guys to think about dropping the words. No, I shouldn't say dropping the words. I should be adding the words. Although, however, similarly, those sort of things are really important because when they're saying compare and contrast, they're going to be looking for those words. Think about how you want to layer it. You can layer it. I would say the better way to layer it is to combine them based on property. Because then that way you can integrate in the compare and contrast words a lot better. Does that make sense? So I'd say my suggestion is when you're writing your answer, talk and do all the conductivity first, compare and contrast the copper and the copper oxide, and then talk about the ductility and compare and contrast the copper and the copper oxide. That's probably a better way to go about answering this question to make sure you get those excellence marks. Because if you just wrote all about copper first and then all about copper oxide second, it doesn't give you that breathing room to do that compare and contrast. So you're better off grouping them by properties instead of grouping them by the substance when answering that one. I'll show you guys the full marking schedule because I don't see a point into me writing it down because it does take a lot of time. So let's pull that up so you guys can see that. Here it is. And put it on the board. All right, there you go. I'll try it. Ooh, it's quite big and long, unfortunately, because of the way this is. I might zoom out a little bit. Hopefully you guys can still read it. Or I might zoom in some sections just so you guys can kind of see it. Cool. What you can see, though, as a generic kind of thing with this, is that there's lots of excellence points. There's 1, 2, 3, one for each section. That was actually quite generous, I thought. Because usually with Part D, you're comparing 2 different types of properties, and usually it'd be like you get both of those properties for the excellence. So I'm surprised they've given you 2 points for that, but I'm guessing that it's pretty kind of generous on their part. And then, so let's just go through and look at the answers. The thing that's tricky about this question, I'll just zoom up so you can see the answer itself, is just the amount of detail that needs to go into it. And that's why for those that are taking both of the exams, if you want to do strategy, I would say organic is probably easier to get the excellence on, simply because there's less writing, and so long as you know the process, you should be okay. With the structure and bonding, it's much harder to get excellence. Luckily, the math questions are really easy for the enthalpy calculations. The thing that's going to let you down, and where you're going to lose your excellence points probably, is going to be this question here, because there's so much writing and layering in that writing. So make sure you're paying attention. It is worthwhile to take your time to kind of organize your answers and like kind of draft them, or just kind of bullet point how you want to order your answers, so that way you have that nice clarity and you have the linking words that you're looking for. So do kind of keep that in mind. Also keep in mind that part of the layering you need to be mindful of is making sure you have talked about the particles and you have talked about the bonds. Both of those should come up in your answer when you're justifying that principle that it has, or that property that it has. So in this case here, we're talking about copper as a three-dimensional lattice of atoms, the positive nuclei with the delocalized electrons, and then you're using that to help justify it. So for example, if we're talking about if we're talking about melting point, you're thinking about, in that case, the strength of the bond and also how much heat energy is involved in that bond, and therefore the melting point is very high. Make sure you have all three layers when you're doing that answer. So I'll repeat that again. Talk about the strength of the bond, how much heat energy is required for it, and then lastly, relate it back into melting point. Make sure you have all 3 points, because I often see that one of those points are forgotten because you guys are rushing your answers. The other thing to remember about the metals and their high melting point is that you want to think about quantity of the bonds as well. So strength and quantity, there's lots of metallic bonds because of that non-directional property it has. This one is quite unique because you don't have the compare and contrast. Most cases they like to compare things with the covalent network because that has such a high melting point, but in this case you didn't. Cool. All right, this one here is your silicon dioxide, and this one you're comparing why it has a hard structure. This is quite unusual. We don't usually see this as a question, like we don't usually ask about hardness as a property. So it's good that you guys have seen this one. But just as a reminder, this covalent network has that strong property because of just the amount of bonds there. So we have a silicon atom bonded to 4 oxygen atoms. Each oxygen is bonded to 2 silicon, and that's creating a really strong lattice with lots of covalent bonds. We know covalent bonds are very, very strong. So that's giving its hardness property. This is quite unusual. You're unlikely to get hardness as a property to explain, but it's good that you guys see it. And it's pretty generic for most things anyway, because most of them, like with the ionic solids and the metals, they're both hard as well. Last one here then is your electrical conductivity and your ductility. So hopefully they have done it as well the same way, where they have done it in the nice way. Oh no, see, they haven't done it in the way that I would have done it. They just talked about copper first and then they talked about copper oxide, but you guys know it's better to talk about property, and then go on to the next property. But I think they've just done it just for ease of writing. But so yeah, when we're looking at this, lots of different kind of layers of details. Be mindful that the ionic solid has that exception that once you have it molten or aqueous, it's then going to conduct electricity. They're definitely going to look for that. And you can see here, they have used a comparison word in contrast. So make sure you're using those words. It's pretty, I would say, straightforward. Let's just look at the excellence points so you guys can see what they're looking for. Hardness is completely explained. Look at all the linking. Make sure you're naming the specific bonds. I don't want to see intramolecular bonds because that's very generic. Tell me if it's metallic. Tell me if it's ionic. Tell me if it's covalent. Okay? I've been trying to catch it and write it when you guys do it. Cool. This one here for the excellence point requires the explanation of covalent bonds, which is not very nice, but just be mindful. That's the level of kind of detail you look for sometimes. Cool. Conductivity is linked to the mobility. So this thing here, I see a lot of people forget to explain to me that in order to conduct electricity, you need a mobile charged particle. So be mindful that you should stick in that sentence. It's a very good sentence. Also be mindful of being when you need to use the word electron versus when you need to use the word ion versus when you need to use the word charged particle. Okay? Charged particle is generic. We're just giving a general definition. Electrons, you are referring to graphite and metals, and then the ions, you're obviously referring to the ionic solids. Ductility is explained by the directionality and the linking of the names of the bonds to the ductility. Make sure, and also one of the ionic bonds explained. Be mindful of this one. It's really good to draw a diagram to explain why ions are brittle. Cool. And then I'll show you guys how the points broke down because I think that's useful to see. So this one was quite hard because they had 3 excellence points, needed all 3 for the E8. But to be fair, it's unusual that they had 3 points, so I'm not surprised they require all of them for the E8. Cool. All right, any questions? No? That makes sense? All right. Hand in any work you want me to look at. I'll try to look at it before you guys have your mock exam. And I'll scan it and email you the work.